Okay, nombor 6. Synthesis 1,2-dibromobutane, dibromoethane from ethanol. Okay, so let's draw our first starting material is ethanol, CH3, CH2OH. And then we are going to produce dibromoethane. Ethane is 2 carbon. Carbon number 1 and number 2 got bromo, 1 bromo, and then this is 2 bromo. After drawing our starting material and our end product, we need to count the number of carbon for the both starting material and final product. Okay, initially we begin with 2 carbon and finally we also end our product with 2 carbon. That means there's no extra or additional carbon. Okay, step yang seterusnya adalah kita check sama ada kita dapat tak start dari depan. Untuk sintesis, kita selalu start daripada belakang. Okay, so we reverse how to produce dibromo alkene. So dibromo, we call it as vicinal dihalide. Vicinal dihalide only produced in alkene. Okay, so here we have alkene as an intermediate. How many carbon to be alkene? For this alkene, because our end product is 2 carbon, so our alkene also need to be 2 carbon. After that, how alkene can be transformed to vicinal dihalide? So we need Br2 in the presence of inert solvent. Therefore, the double bond will be open and both of the carbon double bond will be added by the bromine. Okay, so the bromine will occupy at the empty space of the carbon double bond once the carbon double bond open. Next, we need to consider whether alcohol can produce alkene or not. So we just recall in alkene chapter or in alcohol, there is a reaction to produce alkene from alcohol, which we call it as dehydration of alcohol. So to dehydrate alcohol, we need concentrated sulfuric acid and the condition is heated. Therefore, we are going to remove this OH and eliminate this hydrogen to form this carbon double bond. So to produce 1,2-dibromoethane from ethanol need to be undergo elimination of water via dehydration of alcohol. The reagent needed is concentrated sulfuric acid and the condition is heated. Therefore, we are producing alkene. Next, alkene react with the bromine in inert solvent. The double bond open and produce 1,2-dibromoethane. Question B. 2,3-pentane diol from 2-pentanol. Okay, this is pentanol. 1, 2, 3, 4, 5. Carbon number 2, we have OH, pentanol. And then 2,3-pentanol. 2, 3, 4, 5. Carbon number 2, carbon number 3, another OH group. Okay, so here we don't have direct reaction that produce vicinal diols. Therefore, we try to recall what chapter that produce diol. The only chapter that we learn that produce diol is from alkene. Okay, before that we need to count the number of carbon from the initial reactant. It is 5 carbon and final product also 5 carbon. Okay, next, to produce diol, it is come from alkene. The only reaction that produce diol is in alkene. We have learned it in alkene. Okay, where the double bond will be here because we are going to add OH here. So double bond at carbon number 2 and 3. And then we need to consider, is there any reaction alcohol to alkene? Yes, we have the reaction alcohol to alkene. And then alkene can form diols. So what are the reagent that required to form diol? It is potassium permanganate, basic condition, and it is cold. So we use this in Bayes test. That is the test to identify the presence of double bond in alkene. Next, alcohol can be converted to alkene. So we need concentrated sulfuric acid and heated. So these are the reactions that produce 2,3-pentanediol from 2-pentanol. C. 2,3-dimethyl-2-butanol from propene. Okay, now let's draw our propene. Propene is 3 carbon, 1, 2, 3, and double bond. CH2, H, CH3. Okay, we are going to produce 2-butanol. 1, 2, 3, 4. 2-butanol. And then 2,3-dimethyl. 1, this is carbon number 2. Number 3 got methyl. Okay, we cannot produce directly because it involves the increasing number of carbon. Initially, we begin by 3 carbon. But then, at the end, our product has 6 carbon. From 3 to 6 carbons. So once we encounter the reaction that beginning from less number of carbon and finally produce high number of carbon for the final product, that means it must be the possible reaction that we undergo is the reaction with the Grignard reagent. Okay, so kita boleh buat nota kat sini. Jika number carbon bertambah, bilangan carbon increase. So sintesis mungkin melibatkan Grignard reagent. Bukan mungkin, tapi for sure we are using Grignard reagent. Okay, so let's check this alcohol. It's belong to tertiary alcohol. So kalau dapat tertiary alcohol, apa yang kita kena buat? Kita tahu tertiary alcohol is come from the reaction of Grignard reagent plus ketone. Baru dapat tertiary alcohol. Okay. So we have two options here. Never mind. Okay, so remember this one. So Grignard reagent react with ketone to produce alcohol. Okay. We have two options whether this alkene can produce haloalkene. Okay. Then the haloalkene can react with ketone. React with ketone. Okay, so what is our structure of ketone? Since we already have 3 carbon of haloalkane, 3 carbon. So here our haloalkane must be 3 carbon. Therefore, our ketone must have another 3 carbon ketone. So let's draw our ketone. Step 2, hydrolysis. Okay, this is ketone. Ketone is C double bond O in the middle. So it is propanol. This is the simplest ketone that we can draw. Okay, because we don't have ketone with 2 carbon. This is the simplest ketone we can produce, which is propanol. Therefore, our haloalkane will be Grignard reagent. So where is the location of the Grignard reagent. Ni haloalkene dulu. CH3 H and then H. So this alkene will react with Br. So once they react dengan Br, Br akan masuk dekat sini bila follow Markovnikov. Okay. This haloalkene must react with the Grignard reagent. Must react with magnesium in dry ether. So kita akan dapat haloalkene kita adalah CH3 H MgBr. Okay. Here we can cut into two. So Grignard reagent react with ketone will produce this tertiary alcohol. So this part, okay, this part is come from the Grignard reagent, 3 carbon, and the other part is come from the ketone. So dekat mana tempat potong dia? Cuba tengok kat sini. Tempat potong dia dekat sini, karbon yang tengah ni dan karbon yang ini. Maksudnya sebelum karbon ini potong, ada MgBr terlekat pada dia. So MgBr terlekat pada karbon number 2. Inilah. Kemudian this O is come from the ketone. It is bonded to carbon number 2. 1, 2, 3. So betul tak CO ni duduk dekat carbon number 2? Ni, carbon number 2. Okay. So kalau kita tak percaya, kita lukis balik and then kita combine. Adakah kita dapat struktur yang sama dengan ni? Kalau nak tahu struktur tu sama ataupun tidak, kita boleh namakan struktur ini, dan hasil combination produk yang kita buat, yang kita cantumkan ni, mestilah mempunyai nama yang sama. Okay. Alright. So itu saja untuk soalan 6.